Hi, and welcome back to Elementary Algebra. I'm your instructor, Amy Fuchs-Steiner. This is section 9.2, and we are going to talk about completing the square. Now, completing the square can be a difficult process for some. Admittedly, I am going to try and talk you through this so that you understand what it is you're doing. We're going to begin with just an idea of what completing the square is. So in 9.1, part of what we did is we saw that when you had a perfect square binomial, so if you had something like x plus 3, and then you squared that and it was equal to another number, you could take the square root of both sides and then complete the problem from there. What we're going to be doing today is forcing that perfect square trinomial on our algebra problem. So we are going to be manipulating the algebra problem that we're given so that it looks like a perfect square binomial. Okay? That is our whole purpose. We are basically putting paint on a pig. So we are going to try and pretty up this algebra by forcing it to look like a different type of problem. All right? Now, you need to remember perfect square trinomials. The perfect square trinomials, once again, are the idea that you could take a binomial like x plus a, and when you squared it, you got a pattern where the first one is squared, the middle term is twice the product, or 2 times a times x, and the last term is the a squared, right? Similarly, if you took x minus a and you squared that binomial, we consistently get a pattern of x squared minus 2 times a times x plus a squared. In both of these cases, notice that if we take the 2a and we multiply it by 1/2, or we take half of the 2a and square it, we get the last term squared. So we can manipulate this middle term by multiplying it by 1/2 and squaring it to get the a squared we want. That will take us to a perfect square trinomial. Right? If we do not have a perfect square trinomial, we can manipulate the linear term, that is the a to ax, by multiplying it by 1/2 and squaring it. That will force a perfect square trinomial. So I've got 6 of them to practice here. We're going to complete this. We're going to force these into perfect square trinomials. These are not perfect square trinomials right now, but we're going to force that particular option. So we're going to manipulate these by forcing them to be perfect square trinomials. To do that, I want a different color. To do that, I need to take the linear term, which is 12. On this case, I have x squared plus 12x. This is not a perfect square trinomial. But to turn it into one, I need to take the 12 and multiply it by 1/2. 12 times 1/2 is 6, and square it. So I don't like this purple. It's doing weird things with the color. So this is going to be 6 squared, which is 36. So that will give me an x squared plus 12x plus 36, which, since it's 6 squared, is the same as x plus 6 squared once factored. Okay, so I took x squared plus 12x, and by taking half of the coefficient and squaring it, I was able to create a perfectly square trinomial, which then I can see factors into x plus 6 squared. Why do I want this? Because I want to use what we did in 9.1. I want to use that whole idea of taking the square root of both sides. I know how to do that already. So I want to force whatever they give me so that I can then manipulate it like we did in 9.1. like we did when we took the square root of both sides. Okay? All right, let's try with the second one. Here I have y squared minus 8. Y squared minus 8y. Since minus 8 is my coefficient of the linear term, or of the just y term, I'm going to multiply that by 1/2 and square it. That's going to give me a minus 4 squared, which is 16. This will convert my y squared minus 8y into y squared minus 8y plus 16, which is now a perfect square trinomial, and I can rewrite as y minus 4 squared. Okay? We are completing the square and giving the resulting perfectly square trinomial, and it's factored 4. Okay, number 3, w squared plus 20w. The 20 is my b term, or my linear term. So I'm going to take 1/2 of the 20. Oops. Is it okay if I wrote the 1/2 first? I hope so. 20 times 1/2, or 1/2 times 20. And I'm going to square that. That's going to give me a 10 squared, which is 100. So it is 100 that I need to add to this. W squared plus 20w plus 100. This is now a perfectly square trinomial, which can be factored into w plus 10, quantity squared. Okay, so far so good. Now, what if they're not all even numbers? If you look at problem number 4, that's a 7. So it's a -7, technically. So I need 1/2 of -7 and square that. Well, there's the easy way and the hard way, at least for me. I tend to think of this as just a -7/2. I know a lot of you like to think of it as a -3.5, but I am so used to working in fractions. And it works out slick for this particular application as well, because I know what 7 squared is, that's 49. And I know what 2 squared is, that's 4. So 49 over 4 is what I need to add to this binomial to make it a perfectly square trinomial. And maybe you're saying, okay, Amy, that looked basic enough, but now how do I know what it factors into? Well, we know it's going to factor into a z, and we know we need a minus because our middle term was minus. So what's our n term going to be? Well, let me show you if you haven't figured it out already. When we took half of 12, we got a 6. And what did our n term figure out to be? When we took half of -8, we got a -4. And what did our n term turn out to be here? And when we had a 10 squared, what did we need here? So what were we squaring? 7/2. So this will be x minus a 7/2 squared. Right? Let's try her again. Here we have a -11. So we'll need 1/2, or I'm sorry, that's a +11. We'll need 1/2 of 11 squared, which is 11/2 squared. That means what I need to add to this binomial to make it a perfectly square trinomial is 11 squared, or 121, over 2 squared, which is 4. So this will be r squared plus 11r plus 121 over 4. This factors into r, what's my n term going to be here? Plus 11/2. Quantity squared. Last one, d squared minus 15d. So I'm going to take 1/2 of a minus 15, and I'm going to square it. That's a -15/2 squared. So negative 15 times negative 15 is 225. 2 squared is 4. So 225 divided by 4 is what I need to add to this binomial to make it a perfectly square trinomial. D squared minus 15D plus 225 over 4. Whoops, 225. I said 5 and I wrote 4 over 4. Or in factored form, this will be a D, middle term, minus, what did I square? 15 over 2. Quantity squared. Right? We have completed the squared and given the factors for the binomials that we were given. This is a skill that we're going to be using when we go ahead and use this particular method to solve quadratic equations. All right, so here we go. We're going to solve this quadratic equation by completing the square. We're going to be sure to give exact solutions. So what are we going to do? Well, here we go. On the right-hand side, we have an x squared. Let me go back to my black. We have an x squared minus 9x is equal to 5. So I want to take this x squared minus 9x, and I want to add in the term that will complete the square. That's got to equal 5 plus whatever I added on the left side, I also have to add on the right side. I've got to add the same thing to both sides of my equation. What am I adding to both sides of this equation? Well, I'm going to take half of the negative 9 squared. I need to add that to my left side, and I need to add that to my right side. Right? So that's going to be a negative 9 over 2, which is going to be 81 over 4, and 81 over 4. So I am adding 81 over 4 to both sides of this equation. On the left side, that's going to give me x minus 9 over 2 squared equal to, now, if I have 5 plus 81 over 4, I'm going to write these with a common denominator. 20 over 4 plus 81 over 4. So this is going to give me x minus 9 over 2 squared is equal to 101 over 4. Why would I do that? Well, on the left side now I have my entity squared equal to a single number on the right side. So now what I want to do is take the square root of both sides. And just like we were doing in 9.1, the squared root and the square cancel each other out, leaving me with x minus 9 over 2 is equal to, this would be the positive negative square root of 101 over the square root of 4. Well, what's the square root of 4? X minus 9 over 2 is equal to the positive negative 101 over 2. To isolate the x, I'm going to add 9 over 2 to both sides. So x would be equal to 9 over 2 plus or minus the square root of 101 over 2. Since these are the same denominator, we could write this as 9 plus or minus the square root of 101 all over a 2. This is the exact solution. If I need the decimals, I'm going to split this into two different parts. If I need the decimals, I'm going to say x is 9 plus the square root of 101 over 2, or x is equal to 9 minus the square root of 101 over 2. Okay. Do you want to try a bunch? Like, I've got a bunch of these. So if you want, you can skip to the end, or you can grab a snack and a drink, because I'm going to need a tall glass of water after this. Okay. We're going to complete some squares, we're going to give some exact solutions, and we're going to check some answers. Alrighty. These we do have a trick here. I want this x squared plus 10x to be on a side by itself. So I'm going to add the 4 over to the other side. Then I'm going to take the x squared plus 10x, and I'm going to add what I need to complete the square. And on the other side, I have to add the same thing to complete the square. What am I adding? I am adding 1/2 of the 10 squared. So half of 10 is 5 squared. 5 squared is 25. So 25 is what I'm adding to the left side and to the right side. This will give me x plus 5 squared is equal to 4 plus 25, which is 29. Now, just like we did in 9.1, we're going to take the square root on both sides. So x plus 5 is equal to a positive negative square root of 29. And then I'm going to subtract the 5 over. So x is a minus 5 plus or minus the square root of 29. This gives me the exact solution, which I have not checked yet. So I do need to check it. All right, when I go in to check it, I'm going to check a negative 5 plus the square root of 29. So that's going to give me negative 5 plus square root of 29 squared plus 10 times a negative 5 plus square root of 29 minus 4 is equal to 0. Okay, I'm going to do this without a calculator and see how it goes. So binomial squared. Square the first one, 25. Multiply together and double, minus 10 square roots of 29. Square the last one, plus 29. Distribute, minus 50, plus 10 square roots of 29, minus 4. Does that equal 0? Well, luckily I can see I've got a minus 10 square roots of 29 and a plus 10 square roots of 29. So those two will cancel. 25 plus 29 is 54. Minus 50 is 4. Minus 4 is 0. So I do get a 0 equals 0. That guy checks. If I need to check negative 5 minus square root of 29, that's going to be a negative 5 minus square root of 29. Oops, forgot my square root. Squared plus 10 times a negative 5 minus square root of 29 minus 4 equals 0. So that's going to be 25. Multiply together is a positive 5. So plus 10 square roots of 29 double. So, right, multiply together is a positive 5. Doubled is a 10. Square the square root of 29. That's just going to be 29. Minus 50 minus 10 square roots of 29 plus 4 equal to 0. So I put all that in. 10 square roots of 29 minus 10 cancels. 25 and 29 is 54. Minus 50 is 4. That is a minus 4. 4 minus 4 is 0 equals 0. So I know they check. And there we go. That's a negative 5 plus or minus the square root of 29. Yikes. Okay, next. Y squared minus 12y plus 3. In order to use the binomial, I need to add the 3 over to the other side, lest it mess up my perfect square trinomial. So this is going to be y squared minus 12y plus some is equal to a negative 3 plus some additional constant. That additional constant is going to be half of the negative 12, half of your middle term, so half of negative 12 squared. And if I add it to the left side, I have to add it to the right side. 1/2 times a negative 12 squared. That's going to be a negative 6 squared, which is 36. I am adding 36 to both sides of this equation. On the left side, that's going to factor into a y minus 6 squared. And on the right side, here we go. On the right side, we're going to end up with a negative 3 plus 36, which is a positive 33. Now that I have a perfect square here on the left side, I can square root it. And I can also square root the right side, giving me a positive negative square root of 33. To isolate the y, I will add 6 over. So I have y is equal to 6 plus or minus the square root of 33. We then want to check both of our answers. So if I check 6 plus square root of 33 squared minus 12 times 6 plus square root of 33 plus 3, I should get 0. Square multiply double square, so that's going to be a 36 plus 12 square roots of 33 plus 33 minus 72 minus 12 square roots of 33 plus 3 equal to 0. We want to get 0. Okay. So here I've got a 36 plus 33. That's 69. Yep. Minus 72 is a negative 3 plus 3 is 0. So these numbers are all going to cancel out. And then I have a positive 12, 33, and a negative 12. So those guys shall also cancel out. And we get a 0 equal to 0. And she checks. Now if I do the same for 6 minus square root of 33, whoops, minus 12, 6 minus square root of 33, plus 3 equal to 0. Whoops, squared. Okay, so that's going to be 36 minus 12 square roots of 33 plus 33 minus 72 plus 12 square roots of 33 plus 3 equals 0. All right, 36 plus 33 is 69 minus 72 is negative 3 plus 3 is 0. So those, and then I've got a minus 12 and a positive 12. And I still get a 0 equals 0. And that also checks. And yes, indeed, those guys are going to work out just fine. And y could be 6 plus or minus the square root of 33. All right. We are going to complete some more squares and give exact solutions. I don't have these ones checking. We do know how to do that now. And while I do suggest you do that on your own, and it might prove to be an issue for me at this point, I'm going to go ahead and do these without checking them in the interest of time. All right. It may come back to bite me. We'll see. Here I have m squared minus 8m plus 9 is equal to 5. We want to turn this into a perfect square binomial. To do that, I'm going to keep the m squared minus 8m. And I'm going to move the 9 over to the other side so it doesn't mess up my perfectly square binomial. So this would be 5 minus 9, which is a negative 4. Now, I'm going to add the constant necessary to turn this into a perfect square trinomial. And if I add it to the left side, I must also add it to the right side. So what will that perfect constant be? Well, it's going to be half of the negative 8 squared. So it's going to be a negative 4 squared, which is 16. And if I add that to the left side of my equation, I must also add it to the right side. Why? Because it's an equation. They got to stay equal. So negative 4 squared is another 16. This leaves us with a factorable perfect square, m minus 4 squared. Again, if I square the first one, I get the m. If I multiply these two together, negative 4m, and double it, I get the negative 8. And if I square the negative 4, I get the 16. All right, that's going to be equal to a negative 4 plus 16, which is 12. I now want to take the square root of both sides as we did in the previous section. So m minus 4 is going to be equal to positive negative square root of 12. Can you simplify the square root of 12? Well, it is 4 times 3, and 4 is a perfect square root. So this would be m minus 4 is equal to a positive negative 2 square roots of 3. To finish this off, I'm going to add the 4 over to both sides. Or I'm going to add the 4 to both sides to isolate the m. So I get m is equal to a 4 plus or minus 2 square roots of 3. This is the exact solution, and that's what we have been asked to give is the exact solution. M is equal to 4 plus or minus 2 square roots of 3. That is 2 answers, just FYI. This is 4 plus 2 square roots of 3 and 4 minus 2 square roots of 3. Okay? All right. Similarly, for number 11, I have a squared plus 2a minus 7 is equal to 1. I want to turn this into a perfect square trinomial, much like we have been doing. So I'm going to take that 7 and I'm going to add 7 to both sides. So I have a squared plus 2a is equal to 8. I did that by adding the 7 to both sides. Now, I'm going to take both sides of these equations and add what I need to on the left side to turn it into a perfect square trinomial. That means I must also add that same thing to the right side. What am I adding? Well, to make it a perfect square trinomial, I need to take half of the middle coefficient, half of the linear coefficient, and square it. That's going to be a 1 squared, which is 1. I need to add this same thing to the other side. So 1/2 of the middle coefficient 2 squared, which is a 1 squared, which is 1. So this is going to give me, on the left side, this is a perfect square trinomial. So the a squared plus 2a plus 1 is an a plus 1 squared is equal to a 9. Now I want to take the square root of both sides. As I have a perfect square isolated here, I can take the square root of this, and that has to be the same as the square root of the right side. So we know a plus 1 is going to equal a positive negative square root of 9. Square root of 9 is 3. So a positive negative 3. This means that a is going to be a negative 1 plus or minus a 3. Now, I probably won't leave it this way. I would probably break this into a negative 1 plus 3, which is a 2, and a negative 1 minus 3, which is a negative 4. As I can do those two, I would go ahead and run through it and give the exact answers. All right, I'm going to keep on moving. We're going to solve. This one says to check. I might not check. Checking takes too long, and I know we've already been at this a good half an hour, so I'm going to say not checking this. Eliminate that. You should do it. I'm not modeling good behavior. All right. X squared plus 5x minus 2 is equal to 0. Again, I want to force a perfect square trinomial, so I'm going to keep the x squared plus 5x on this side, and I'm going to add the 2 over to the other side so it does not mess with my perfect square trinomial. I'm not eliminating it. I'm just sort of pushing it out of the way. All right? Now, I'm going to add to both of these the term needed here in the last place that will make this a perfect square trinomial. But whatever I add on this left side, I must also add on that right side. What am I adding? I'm going to take half of that linear coefficient, so 1/2 of 5, and I'm going to square it. That's going to be 5 over 2 squared, which is going to be 25 over 4. I don't want to know what that is as a decimal. It's going to be too difficult to manipulate if you put it in there as a decimal. We'll need the decimal maybe in the end, but not right now. So I need to add that same thing, 1/2 times 5 squared, or 5 halves squared, which is 25 over 4. Yes, I'm writing it out on both sides. Yes, I understand that you may only need to write it out on one side, but you do need to add it to both, okay? All right. Now, this will be factorable. We have forced a perfect square trinomial here. So this will now be x plus 5 over 2 squared is equal to, well, we have 2 plus 25 over 4. We want to get a common denominator. So this will be 8 over 4 plus 25 over 4. So we have an x plus 5 over 2 squared is equal to 33 over 4. Now I want to take the square root of both sides. So x plus 5 over 2 is going to be equal to plus or minus the square root of 33 over 4. Now, keep in mind, the square root of 33 over 4 is the square root of 33 over the square root of 4. So that's going to be the square root of 33 over 2. I want to simplify that as much as I can, in part because I can't have square roots in the denominator. So whenever possible, I want to eliminate that as an option. So this means that x plus 5 over 2 is equal to a positive negative square root of 33 over 2. Not quite done. I still need to isolate the x. So I want to subtract 5 over 2 from both sides. So x would be a negative 5 over 2 plus or minus square root of 33 over 2. I could simplify this one step further because I do have a common denominator here. So our x would be a negative 5 plus or minus the square root of 33 all over 2. Beautiful. Okay. Trying number 13. Similar story here. I've got a y squared minus 7y plus 11 is equal to 2. I want to complete the square on this. And that means I want to force a perfect square on that left-hand side. So I'm going to keep the y squared minus 7y. And I'm going to subtract 11 over. So 2 minus 11 is a negative 9. Not so much... I want to subtract 11 over to make way for the missing term in my perfect square trinomial. So this will be y squared minus 7y plus some missing term is equal to a negative 9 plus some missing term. That missing part is going to be 1/2 times the negative 7 squared. That's the part that's missing. Half of the negative 7 squared, or a negative 7 over 2 squared. That's going to be a negative 7 squared, which is 49, over 2 squared, which is 4. So I'm going to add a 49 over 4. And if I add it to the left side, I've got to do the exact same thing on the right side. (49/4). So on the left side now, this is a perfect square trinomial. I forced it to be so. I made it so. Captain Picard, make it so. Number 1, you are the number 1. You make it so, number 1. So now we're going to have y minus 7 over 2 squared is equal to negative 9 plus 49 over 4. I need a common denominator. Negative 9 times 4. So it's going to be a negative 36 over 4 plus 49 over 4. So I'm going to have y minus 7 over 2 squared is equal to, is that 13 over 4? I think it is. Okay. Now that I have a single number on the left side and a single thing squared, well, actually it's a binomial squared on the right side. I'm going to take the square root of both sides. So y minus 7 halves is going to be a positive or a negative square root of 13 over 4. We've talked about this up above. So this could be rewritten as y minus 7 halves is equal to a positive negative square root of 13 over the square root of 4. That's 2. Now I'm going to add 7 halves to both sides yet because I still need to isolate the y. So y would be 7 halves plus or minus the square root of 13 over 2, which this is a common denominator. So I can now do y is equal to 7 plus or minus the square root of 13, all of that over 2. Keeping in mind, this does represent two different numbers. It's 7 plus the square root of 13 over 2, or I don't want that to be like a decimal line or like a fraction bar. It's not a fraction bar. 7 minus the square root of 13 over 2. There's two possible answers there, which makes sense because it's a y squared. It should have two possible answers, right? Okay. Kicking it up one last little bit. And the last little bit that I'm doing here is what happens when you have a quadratic equation that doesn't start with just an x squared, but rather has like a 2x squared. And I'm going to show you how to do this one. Full knowledge, this is challenging. Full disclosure, this one is challenging. So here's what we're going to do. The idea here is that the first thing we're going to do is we're going to convert this. And we're going to convert this into one we're familiar with by going ahead and dividing everything by that leading coefficient of 2. Okay? If I divide everything by 2, I now have an x squared minus 5x over 2 minus 3 over 2 equal to 0. It's not my favorite thing to do. I'm just going to take a breath, right? I'm going to take a breath and I'm going to say, okay, same process. Numbers are a little bit more challenging, but the process has not changed. We still want to force it to be a perfect square trinomial. And all of our steps in the middle stay the same. Do the numbers get a little bit more challenging? Yep, they do. But let's practice our process and go slow. So, just like before, I'm going to keep the squared term and I'm going to keep the 5x over 2. I'm going to take that minus 3 over 2 and I'm going to add 3 over 2 to the other side. I'm going to add it to both sides, actually, in order to get it out of the way. So that will equal 3 over 2. I just want to be able to add the same thing to make this a perfect square trinomial. So I still need to add a term to that left side to make it a perfect square trinomial. Whatever I add on the left side, I need to also add on the right side. Again, what am I adding? I have to take 1/2 times the coefficient negative 5 over 2. What makes it harder? That it's 5 over 2. But it's the same process. So negative 1/2 times a negative 5 over 2 squared. Now that's going to be a negative 5 over 4 squared, which is a negative 5 squared. That's 25 over 4 squared. That's 16. Now, whatever I add on the left side of my equation, I must also add on the right side of my equation, 25 over 16. Do I need to write out all of that 1/2 negative 5 over 2? Do I need to write this bit out? Some of you won't, and that's okay. As long as you're adding the exact same thing on both sides here, we've kept it legal. Negative 5 over 4 squared, which is 25 over 16. Okay. So now, on the left side, this is now a perfect square trinomial, which can be rewritten in factored form using an x. That's negative, so we'll need a minus. And what did we square? 5 over 4. Okay, so it'll be x minus 5 over 4. On the right side, I need to get a common denominator. So for 2 and 16, the common denominator is 16. I need to multiply the denominator by 8 and 3 by 8. So that's going to be 24 over 16 plus 25 over 16. So this will give us x minus 5/4 squared, not messing with that yet, is 49 over 16. Now that I have this as one number, and I also have the left side as one entity squared, I can take the square root of both sides. Okay, this square root and the square will leave me with an x minus 5/4 equal to a positive negative. Square root of 49 is 7. Square root of 16 is 4. So this is going to leave me with x minus 5/4 is a positive negative 7 over 4. Now, keep in mind, this means a plus 7/4 and a minus 7/4, two options. So now what we're going to do is we're going to add 5/4 to both sides. So we're going to get a 5/4 plus or minus 7/4. This gives us two possible options. We could have x equal to 5/4 plus 7/4. That's 12/4 or 3. Or we could have x equal to 5/4 minus 7/4, which is a negative 3/4. And we have our two possible solutions. X is 3 or negative 3/4. There we go. Hoy vey. Want to try it one more time? One more time. Okay, one more time. Here we go. I'm going to reorder this. I'm going to move the 18x over. So this is going to be a 3x squared minus 18x plus 21 equals 0. These are all divisible by 3. See how I've got a leading 3? I don't want a leading coefficient. When you use the completing the square method, you do not want a leading coefficient. So I'm going to divide by 3. Okay, that's going to give me an x squared minus 6x plus 7 equals 0. Now, to complete the square, I need to move that 7 over to make room for the term that will complete the square. Right? What term am I adding? Well, whatever I'm adding to that left side, I am also adding to the right side. And specifically, I should be adding 1/2 of this middle term squared, or a negative 3 squared, which is 9. If I add it to the left side, I must also add it to the right side. This will give me x minus 3 squared on the left side equal to negative 7 plus 9 is 2 on the right side. Taking the square root of both sides, we will have x minus 3 is equal to a positive negative square root of 2. Now I'm going to add 3 to both sides. So we will have x is equal to 3 plus or minus the square root of 2. That is my exact solutions. I do have 2 as it was x squared. I should have a 2. Okay. There were a lot of examples in this. But because I know when I have a lot of examples, people like to know the process written out as well. So that's what I have on my last page here. Whoops, if I can get it to turn. Yeah, man. Okay. Here we are. So, we can't really read some of these. What are the instructions? First of all, arrange your equation to be in the form ax squared plus bx is equal to c. We want the first two terms, the ax squared and the bx, on the left-hand side of the equation, and we want the constant on the right-hand side of the equation. Next, we want to make space and add half of the coefficient of your x term and square it to each side of the equation. So half of the linear coefficient squared. We're going to add that to both sides. We're going to factor the quadratic side. It is a perfect square trinomial, which means it should factor into the x plus or minus the b over 2, whatever that was. And we're going to simplify the side with a constant. So we're going to go ahead and factor the right side. We're going to simplify the left side. Once we've done that, we should be able to take the square root of both sides as we did in 9.1. Then we want to make sure we're using the simplest form of that square root. Particularly when you need exact answers, you want to make sure you're using the simplest form. Now, it is good form to check your answers, right? If you have checked your answers, you want to make sure that you have two working solutions, or so that both solutions work, right? You want to check two solutions. And you need to check the instructions to see if you're supposed to give the exact answer or the decimal answer. Because sometimes they'll want exact and sometimes they'll want decimal. And I can't tell you which is which. You have to read the problem to know, right? There's a lot of stuff wrapped into this one. If you have any questions, please don't hesitate to reach out. I myself am willing to help, and we all know that Math Center and Julia is also there to help you. And we all do want to see you succeed. Until next time, thanks.